Hello everyone. So in this class I am going to prove a lemma. Look here. The statement of this lemma is if pi is a one form on E3, then exterior derivative of d pi equals to 0. Okay, this is the statement of the lemma. Now we have to prove that d of d pi equals to 0. Okay, look here. Now let's start to prove the lemma. So first we let us consider the pi equals summation fi into dx. So statement alla kottidare pi is a one form on E3 anta. So now here this summation can be represented as f1 dx1 plus f2 dx2 plus f3 into dx3. Therefore pi is equals to this one. Now we find the exterior derivative of this function pi. So therefore d pi equals df1 wedge of dx1 plus df2 into wedge of dx2 plus df3 into wedge product of dx3. Okay. Now we already well known about that df1 can be expressed as del f1 by del x1 into dx1 plus del f1 by del x2 into dx2 plus del f1 by del x3 into dx3 into wedge product of dx1. Plus similarly we have to expand this dx2, that is del f2 by del x1 into dx1 plus del f2 by del x2 into dx2 plus del f2 by del x3 into dx3 into wedge of dx2. Plus similarly this term can be written as del f3 by del x1 into dx1 plus del f3 by del x2 into dx2 plus del f3 by del x3 into dx3 into wedge of dx3. Okay. Now compute the wedge product of these three. So these three terms. So finally we get d pi as, look here. So after computing the product of those, so we get d pi as, or d pi is equals to del f1 by del x2 into dx2 into dx1 plus del f1 by del x3 into dx3 into dx1 plus del f2 by del x1 into dx1 into dx2 plus del f2 by del x3 into dx3 into dx2 plus del f3 by del x1 into dx1 into dx3 plus del f3 by del x2 into dx2 into dx3. Okay. Now look here. From this equation, observe here, from this term and this term. So we have to consider these two terms. Observe from these two terms. Look here, from using the anti-commutative property, so this term can be represented as, look here, minus del f1 by del x2 into dx1 by dx2. Can we write like this? Yes, we can write like this by using the anti-commutative property. Now observe this term and this term. Look here, here dx1 is there, here also dx1 is there, here dx2 is there, here also dx2 is there. So these dx1 and dx2 are common in these two terms. We have to take that as common terms, dx1 and dx2. Then the remaining terms is del f2 by del x1 minus del f1 by del x2. Plus similarly next we consider this term, and here dx3 and dx1 is there. So next we consider these two terms. Here also, so we apply the anti-commutative property, we get minus df1 by dx3 into dx1 into dx3. Again we observe these two. So here we have to take dx1 by dx3 as common terms. Then the remaining is del f3 by del x1 minus del f1 by del x3. Similarly, next we consider these two terms. So by using the anti-commutative property, this will becomes minus del f2 by del x3 into dx2 into dx3. Okay. So again we are observing these two. Here dx2 and dx3 is common. We have to take it outside. Then the remaining is del f3 by del x2 minus del f2 by del x3. Okay, simplify ಮಾಡೋದು ಯಾವ ರೀತಿ ಅಂತ ಗೊತ್ತಾಗಿದೆ, ಕಾಮನ್ ತೆಗೆಯೋದು. Okay, next. So therefore d pi is equals to, we get this equation. Next we apply the anti-commutative property to the above equation. So anti-commutative property means d of d pi is equals to this one dx1 dx2 into wedge of dx1 plus this one into wedge of, here dx3 is there, dx2 ಕಾಣಿಸ್ತಿದೆಯಲ್ಲಿ, ಇದು dx2 ಕೆಳಗಡೆ ಬರ್ದಿರ್ತೀನಿ ನೋಡಿ, this is dx2.